All right. Welcome to this week's scheduling meeting. And this meeting is being recorded. So be aware of what you are saying. It will be public in the internet. Okay, let's go through the agendas today. The first one is by Aldo, multiple profile graduating to beta. So basically, multiple profile was introduced in the last release, 1.18 release. So actually, it wasn't controlled by a feature gate or something. So it's just in place, and you can use the multiple profile to craft different strategies to schedule your workloads within one scheduler binary. So it's a very useful features so that you don't need to use multiple schedulers in different schedule processes to manage different kind of workloads. So Adolf, do you want to add more things on this going to beta?
Yeah, so the question is, what does it mean to graduate to beta? And I can only think of basically the configuration API moving forward to beta, which is what we're already planning. So it's just basically to get the consensus from everyone that they are basically the same thing, and we can proceed with both.
Yeah, I feel the same. Yeah, in terms of the multiple profile features itself, it wasn't specifically controlled by a feature gate. And I think there's a couple of items that depends on the component config graduating to V1 beta 1, right? The profiles one is one, and I recall there is some other issues also need to change the arguments or something of the component config. That is also one, I think.
Right, that depends on the implementation of volume binding, which is still ongoing.
I see.
Volume binding plugin. And once that's there, we should move the argument to that plugin. And that's much the only dependency there.
Yeah, and also I have one, depends on the V1 beta 1, is the post filter definition, extension point definition. So the post filter interface will be introduced. And go ahead.
Since that's a new field, it's not really a problem.
Yeah, addition is fine. Yeah.
Yeah, but well, somewhat related as well is the merging of reserve and unreserve. That definitely needs a new version.
Yeah, so, that is also one. Let me.
Yeah, so if you have any concerns, just put in the issue. But otherwise, it looks like most people are in favor of merging these two, because it brings easiness in the configuration of a profile.
Yeah,
I have a couple points. So one is scheduler profiles is a component config feature, so it's not something to by flag. It makes sense just to graduate it to beta as we graduate component config to beta. I don't think you have any other option to not graduate it to beta if you're going with component config to beta. And the other thing is merging reserve and reserve. Yeah, this has been discussed before. I think it makes sense. We should move forward with that. Similar to what we did with score and normalized score, just fuse them into one plugin. I mean, one argument could be the default scheduler is not using them right now, so it's easier to convince people that it's not going to have a big impact. I understand that out of 3 plugins might be using them, but the framework is alpha in general still. So I don't see an issue with this, and we're lucky that we're going to beta in this cycle, so it's fine. I think we can remove them. We can merge them while we're moving to beta.
Okay. In that case, I'll proceed with the CAP, which I plan to send early next week. The
Okay, sounds
graduation
good.
CAP.
Yeah, I just list all the items aware of to the agenda, so that for anything missing, please leave a comment there, and any incorrect wordings, yeah, leave a comment. Okay, the second one is from Dashpo and Mike, tracing in the scheduler.
Yeah. So I think David is here. I asked him to come join us, and I was hoping that we could start off. You could talk a little bit about what OpenTelemetry is and what his goals are around that CAP that's linked upstream, and then if you don't mind, David, and then I can show a quick demo of how we can implement it specifically for the scheduler. So David, do you think you could just cover a little bit about what is OpenTelemetry?
Yeah, sure. I'll introduce myself first. I'm David Ashpole. I've been working with SIG for a couple of years now, and I'm the tech lead for SIG instrumentation. And I've been working on trying to use tracing in Kubernetes for almost 2 years now. I presented at KubeCon last November, and there's a cool video of it as well. That'll probably be a little bit more in depth than what I do here today. Let's see. So first I'll talk about OpenTelemetry. OpenTelemetry is, it does tracing and it does metrics. And it can correlate between the two. And from what I understand, they're also working on logging. So the whole idea is they want to define a component level telemetry API where you can instrument your component with OpenTelemetry client libraries and then choose either at export time in your component or even have it transmit the telemetry to some agent that's running separately that decides what backend to send your information to. So for example, I could instrument my component with the OpenTelemetry client library and then send traces to a collector, which then could send to Stackdriver or Zipkin or Jaeger or any of the tracing backends. So OpenTelemetry is really cool. And it's actually quite a nice fit for Kubernetes because as developers and maintainers of Kubernetes, we don't want to tie ourselves to a single backend for tracing or for metrics. We much prefer using something that that we can plug into any of the providers' tracing systems or even to some of the cool open source ones that are part of the CNCF. I'm actually going to present super quick.
So one quick question there.
Yep.
So you're talking about also about metrics. Is this somehow related to the effort in instrumentation from Smarter Clayton, I think, about pod resource utilization?
Oh, no. So actually, the current proposal that I have only talks about tracing. That's because we already have a standard for metrics in Kubernetes, and it doesn't seem like there are any major benefits to moving away from Prometheus right now. Everyone seems quite happy with it, and everyone knows how to use the client libraries, and we have a lot of tooling built around it. So at least for right now, the current proposal is just to use OpenTelemetry for tracing. And Smarter Clayton stuff is completely separate from that and is about adding new Prometheus metrics, not about OpenTelemetry isn't a specific set of metrics. It's you could compare OpenTelemetry more to Prometheus, at least the Prometheus text format, than to what Clayton has been talking about.
That sounds good.
Cool.
Yeah.
Cool. So I'll talk really briefly about how. So there are a couple pieces to trying to get tracing to work in Kubernetes. One is tracing API requests. So normally the way tracing works is you send a request to some front end, which then propagates that request throughout your system. And tracing is a context-aware telemetry, meaning that there's some context that is sent along with the request through your system, and in the end, you get this thing called a trace composed of spans, which forms a tree of work that's quite easy to reason about and is very useful. But actually, there's only one component in our system that acts like this, and that's the API server. So if I send a request to the API server, that sends it to its backing storage, that comes back. And that actually looks like sort of the traditional tracing model, where you're serving an RPC and you get a nice tree. Well, for us, it's a fairly simple tree, but you get a tree of requests that comes back. So that's part one of the proposal, which actually for 1.19 is all I'm planning to tackle. Part two of this effort is to extend that to be able to propagate context through objects so that controllers can add their traces as well. And the basic idea is that we can propagate context through HTTP by encoding something in an HTTP header and then decoding it when it gets to the client. If we think about controllers and how they work, the proposal is that we can actually take the span or trace context, put it in an annotation, and then the next controller can read that. And so I'll do a super quick demo if that's all right, and then I'll let Dame talk about his work as well. So I have this. This is actually, I think, based on like 1.16. So this demo is quite old and actually uses Open Census under the hood, because that's what I had at the time when I built the demo. But it's kind of a fun way just to see sort of like what I'm talking about and what sorts of information you could get from it. So if I start out by creating some simple config map, and I've added a trace argument to this, and I've got this set up with, it's running some OpenTelemetry collectors, and those are sending to a Zipkin backend. So now if I go over here to Zipkin and try and find my traces, lo and behold, I have this trace from creating the config map, where I can see the API server received the request here, and then it sent a transaction to etcd here. And so you can sort of see how that work broke down. Pretty simple, quite useful if there are complicated API requests, like ones that have to go through a series of admission controllers or aggregated API servers or anything like that. But for our simple case, it's not super useful, say. I could do something more fun though. I could create a pod, and this is probably where, of course, everyone here is mostly interested in. So I can go, let's see, it's been a while since I've navigated this. If I create a pod, that of course is more interesting. We have our initial request to the API server and request to etcd, but then, for example, I have a trace from the scheduler where it's calculating what node to schedule it on and creating the binding object to perform the scheduling. And then I even have some traces from the kubelet, including updating status. I have traces from container runtime calls to the CRI, and then the final status update that brings the pod to running. So that's pretty cool. And that works by, yep.
What is the scheduler? Like the traces I was imagining is that like you're tracing an RPC code, right?
Mm-hmm.
Is that so from kubectl all the way to API server, and then what? How did it get to the scheduler? The scheduler is actually watching for the pod, so it didn't make any. Yeah.
Yep.
How did the context propagate to the scheduler?
Yep. So basically, in kubectl, we created an initial parent trace context and used that in the request to the API server, and also encoded that in an annotation on the object. The scheduler, when it receives the pod, decodes the context from the object and then uses that for all of its telemetry, including adding a span around the work that it does. Is how I've done it. But then the next controller as well can also read that context and use it for its telemetry as well.
Okay, but then yeah, there's no sequence right between those two things, because each one is watching for the pod. Each controller, like the scheduler is a controller, and then there's another controller watching. They both, did something on the pod, and then they added that information. How does this go back to the? So they will have two different, like another two different items or like sub items in the new context, and how do they get merged? I guess so it's because there's no order here.
Yep. So this is a tree, and there can be many children of a single parent in a tree, meaning that the initial context that was generated by kube control is actually used for the API server call. So this is one child of the tree. It's used for it's used by the scheduler when it picks up that context from the annotation, and then that same one is also used by the kubelet when it performs its work. So and that's perfectly fine to have. It would be the same, for example, if a server had a single incoming request that then made 3 different requests to 3 different backends, right? Each of those is a child of the initial context that came in, and that's okay.
Right, but you don't know how the time overlaps between these two, between those, like.
Right. So the timing aspect of it here is just all based on the time when work is done. So obviously the span here records some start time and end time, or start time and duration. That's how you piece all of these back together. And then it just orders them by a time.
But clocks are might not be synchronized. So my controller might be running on a different node. And so it will be hard to actually do that.
Yep. This isn't something I'm super knowledgeable about, but I do know that it is a problem for any sort of distributed telemetry, like even logging, for example. If your timestamps are not synchronized across nodes, then you can have logs that are out of order from what actually happened.
Right. The problem is that he would talk about like millisecond. So it it's like the granularity is so small that any drift, it's gonna basically make things.
Right. So this kube scheduler one is quite small. I think the other thing that's important is that hopefully you're not trying to synchronize across 2 components with like nanosecond precision. Hopefully, even though the trace here is very small, the thing that's actually ends up being important is the time at which it happened, which is separated from other traces by some amount of time. But you're right that there can be issues with that.
In my demo, I'll show within the scheduler, like it runs in about 1 millisecond, but it still shows the timeline of everything. So it does get that accuracy within the process if you're handling the context correctly.
Yes.
Like I've done.
So within a process, yeah, it can be accurate. I just want to finish up my demo real quick because this one's kind of fun and shows the sort of power of tracing and how useful it can be. So I created a deployment. Yep.
One question. So is this something that is supposed to, something that you can query at any point later, or is this something that gets lost over time?
Yeah, so that depends on the retention policy of your backend.
Okay.
I think let's see, it's pretty common to have many days of history.
Okay. And then you can attach labels or something to the traces.
Yeah, so technically you attach labels to spans, and you propagate some information along with the context. But yeah, you can think of it like I could attach, for example, the container ID to my container start calls, and then it's very easy for me to be able to search Actually, I used to have a demo where I did that, but I forgot how to do it. But then you can search for specific tags like this container ID, and it'll actually find the span for you and show you the overall trace in which that action occurred.
Okay.
But I just wanted to show super quick the deployment trace, which is interesting because it involves multiple objects. So not only are we dealing with a single pod here, but also we have deployments and replica sets. And it turns out that you can use this same model here to, for example, read in a deployment object in controller 1, and when it creates a replica set, use the context and propagate the context from one object to another when you're acting on an object and creating another object as a result. So it is also possible to use this to propagate context from objects. And that ends up being even more useful. I can see, for example, if there were a single pod that were slow to start, that would become super obvious here. And I can also very easily see the structure of all of the work that's done to start my deployment. Cool.
So thanks, David. I think that really shows a lot of the distributed efforts, that this is like a big goal, right, for more components to adopt this tracing library and hopefully be able to show full traces of the life cycle of objects. What I've done, I'm going to try to share my screen now and show just what that looks like in the scheduler. Let's see, I've never shared in Zoom before, so I think this is doing the right one. I have to allow it. Okay, I just need to quit the app quick because Zoom needs the permissions and it needs to restart for me to do that. So I will rejoin in 1 second, if that's okay. Sorry, everybody.
Sure, no problem.
Any other questions for me?
Yeah, about the annotation, has
Mhm.
already been approved by API folks?
So I've been talking with them for a while. Daniel and I have been going back and forth. For 119, so that hasn't been approved. And we'll see how it goes. I'm not sure if I wanted to do an API change in like object meta or something, I think that would require their approval. If we use an annotation, that I don't know if that would have any problems or not. So that's TBD. But for 119, we're just doing tracing in the API server itself, which is some of the biggest in-tree changes required, and that'll allow us to easily look at adding stuff like this later.
Okay, so in that scenario, you don't preserve anything for now.
What
You
do you?
don't add the annotation or anything else.
Right. So none of this is implemented yet. There was a proposal that was fairly broad, and that we were finding it hard to come to agreement because it involved 7 or 8 SIGs. So we're doing kind of a narrowed down version with just the API server changes for now, and that way we can go one step at a time.
Sounds good. Yeah, it's just the usual concern with annotations is that they can be overridden by users. So if we can move it to an API field in the status, that would be even better.
It does solve some of those problems, but I think there's still some discussion about the model of propagation and how well it works, and so that's been hard to come to an agreement on. So using an annotation, and we can actually do a lot of this out of tree first, will allow us to experiment and try using this much more easily than if we started with an object field.
For sure. That's good. I'll take a look at the cap. This is very, very interesting. I really like it.
So can everyone see my screen right now? I'm hopefully sharing, right?
Yeah, we can.
All right, great. So I've already gone and created a couple pods. Well, the first thing I want to point out is that I'm using Jaeger. David was using Zipkin. And that's one of the other cool things that's provided by OpenTelemetry is they have a sort of standard middleman collector that can it can receive traces in different formats and then translate those traces into other formats for different backends. So if you have clusters that are one's running Zipcan or you're running Jaeger, you want to switch between those, you can just configure this collector to point to the new type of backend without having to recompile or restart anything, which is pretty neat. But right here, I'm just running Jaeger. So I scheduled a couple pods. I want to point out that I've just added spans to just the default filter and score plugins, and it's over 100 spans for one pod's scheduling cycle. So if I look at one of these pods here, each one of these points is, each one of these spans is literally 2 lines of code. It says start span and then defer and end to the span. If you look at my PR, that it's pretty simple code changes, but I'm able to narrow down the entire scheduling cycle for this pod in just this 1.27 milliseconds. And I added a couple logs at different spots to see, you know, what was the suggested host from the scheduling cycle, what nodes were evaluated. I can go into these plugins and specifically see, so we're filtering out one of these nodes here. Why was that filtered out? It was unschedulable for this taint. Things that we can get from logs, but is really tough to parse out and put together into a whole context. But I've got all the filter plugins run for each node. These are collapsible. I mean, that's just part of the backend that you have.
Did you experiment with failed schedule cycles?
Yeah. So this is one that just scheduled all the way through. I added some logs to all these different functions, so I can see the scores that came out for each node that was available. I can see I added, you know, for each plugin, what was the score per node.
So my question is towards like this scenario, you have it and schedule for a few cycles until it's scheduled.
I'm so in my next pod that I've got here, you see it's only 54 spans. This is because I added, just to show like an actual scheduling decision that stops the scheduling cycle. I added a node affinity to this pod that was for a certain node. So you see, I don't know if I can get a good comparison. This was the one with no problems that went through. So on these nodes, no problems filtering. It runs through all of the plugins. This pod has a node affinity on it, and I can see that it just cuts out as soon as it gets to node affinity. And if I look at the reason why, it's because it doesn't match the node selector. So this one, I can see it doesn't even get to the prioritized nodes section because it filtered out all the other nodes either for node affinity or for the taints and tolerations because of it being a master, except for the one.
So this is very cool. My only concern would be like, what's the overhead? How does it scale with odds?
So the actual overhead, I'm not sure about what kind of network each of these spans being reported uses. I think David might be able to answer that. You've talked about the size of the annotations before. I don't know how much network traffic this causes when we're reporting.
It depends on what
spans.
you put into it, right?
Yeah.
Like you're putting here, like too much information, for example, for each plugin, its decision, the scores for each node, and all of that. So
right,
it's something you can't control. You can control.
Yeah, each start-stop span is about a microsecond of latency. And the span itself, the size is going to vary based on how much information you put into it. At base, it doesn't have very much. So yeah, I haven't actually done an estimate, but I know that the spans themselves are exported batched generally to the collector. Yeah, I haven't done any benchmarking in particular. I will say this is an unusually dense number of spans for a single process like this. So we might want to pare this down slightly, but it is kind of a fun demonstration, at least, of the sorts of things you can do with tracing.
Yeah.
Yeah, and so
I
the
wanted,
profiles, is the profiles like done by default, like these timings? Or is that, this is the core thing that you get for free with when you
these
start and
were,
stop span?
yeah, this is what, and what you get for free is basically just like, looks like this, like filter node name. This was just 2 lines of code in the node name filter plugin that says start a span here that says filter node name. So I got the process name, which was the scheduler that I'm running, just because of, I had 3 pods that were all different schedulers and they were interfering with each other. So I've got that sorted out a little bit. But yeah, I mean, I was just trying to put as much stuff as I could into the scheduler to show like how much information we could be getting out of it. Obviously, we probably don't need to see the latency for each different plugin to be running. We're more interested in the outcome of running like the filter plugins on a node. But another cool thing about this library that I found out was that if just because you have the code for tracing, if you don't have an actual exporter configured, you'll just get a no-op trace exporter. So if you don't want to be running this in your scheduler and it's just too much information, you don't have anywhere to store it, or you don't want to be choking up your network, you can just disable that and you don't have this. And I'm sure that we could probably do it we could add flags by levels if we want really detailed traces, enable that just by some spec component config field. But yeah, this is basically what it looks like. I've been using this custom scheduler image for like the past 2 weeks or so to debug all of my work bugs that I've been getting, and I found it incredibly helpful to be able to see at a glance what plugins failed, what the scores for different nodes were. It's given me a lot of insight into scheduling processes that I did not have before.
So Mike,
Yeah.
I suppose that we were adopting this to inject the what you call that, the open telemetry, I don't know, SDK calls or something into our scheduler code, right? So my question is that is there any guidance to follow to give a default settings on which layers we want to plant the open telemetry agent to that? For example,
No, I mean,
yeah, go ahead.
Yeah, I think you get your questions like how many of these would we want to have by default to adopt it? Like what layers we do want to be logging traces at. I think that that's really just up to us, how much information we want to provide. I don't know if there's standards around it.
So this is something that hopefully will be an outcome of the KEP, especially as we think about beta or beyond. One of the issues that is probably going to come up eventually is that most of the tracing backends have a limit to the number of spans that can be in a single trace. And it seems 1,000 seems to be the convention, which becomes very interesting if certain components want to have lots and lots of spans, like say the scheduler, but other components like kubelet or something else also wants to have a large number of spans. So we'll definitely have to keep an eye on how much information we include where, so that I don't think OpenTelemetry defines a standard for the behavior that you should have when dropping spans. I think it's more concerned with just collecting them and sending them. But yeah, a lot of backends will drop spans from traces if the trace gets too many. So
and we can also, like a lot of these don't need to be spans themselves, but we can, if we want to encode logging information to a parent span, some of that
Yep.
might make more
So
sense.
I think that exists.
Sorry, is there like a concept of levels here, such as like log levels, so that you can just set a number and then everything else would be disabled?
There is not. And that's come up in a number of different contexts. There's a couple folks from a company, I forget, who are looking to do request ID logging, which essentially boils down to logging with a trace ID. And they want to be able to have log levels because they see it being very verbose. But generally, the approach that tracing takes is always have super verbose information whenever it's collected, but don't collect all of the spans. And so tracing is built around that idea, which is separate from or different from how logging usually works. And so the idea is if you have a very verbose thing that you're collecting, you should probably only collect it 1 in 10,000 times or something like that. The approach that I had proposed was that by default, all the components don't trace anything. And then you can specify in kube control with -- trace if you want stuff to be traced. That way we don't overwhelm people's trace backends. But yeah, there's also some cool stuff that OpenTelemetry has, like tail-based sampling, where you have the components sample everything, and then you have a component later down the line, for example, take only the slowest traces or traces that are 95th percentile and above or something like that. It can be fairly intelligent about which it keeps and which it drops.
And I think it would be, if we really wanted to, implementing some kind of hacky log level field in our own traces to say, do you start a trace here or a span here? It could be mapped right to check what the K log level is. Just any kind of field that we can set. But anyway, my hope with showing this to us was that we could hopefully be one of those components that starts to get involved in this CAP and try to get this started. And with my pull requests that I've sent, show how easy it is to start to implement this. And ultimately, when it does become more available through other components and those contexts are being attached to pods, we can easily plug into that. But like, I don't know how far this is going to get for people without people taking charge of it and starting to pick it up and work on it. I don't know what the overall status is of the tracing CAP.
So we had, I'd been discussing this with some of the API machinery folks for a while, and we had a KEP that I would say was fairly simple for components to implement. It involved a single line of code and would just generate traces for HTTP and RPC calls. So it wouldn't get stuff like this, but you just had to essentially identify what your parent object was that you were operating under. But we still weren't able to reach consensus on that. And so for 1.19 at least, this isn't anything that is going to happen. But for 1.20, hopefully we can resurrect this and talk about the model with a different set of people. I don't know. We'll see. We'll have to see where it goes. But yeah, definitely, I think the scheduler is one of the places where this will be most useful. And of course, we're happy to keep everyone in the loop. And I appreciate everyone's involvement and feedback as well.
Yeah, that's pretty cool.
So yeah, that's about all we had to say about that. Thanks, David, for coming in and giving us a really thorough background of this, so that I wasn't just starting out and spouting about this randomly to everyone. Just gave some good background.
Cool. Thanks, everyone.
Thanks, David. All right, we are little used out of time, but we can continue the agenda. So Mike, next item is about the cleanup on the dependency to Kubernetes.
Yeah.
Yeah.
Yeah, I know we're a little over time, so I'm sorry. But
No problem.
this is just,
no problem.
This was just something that came up in one of the PRs. I think, Abdullah, you mentioned that we have a bunch of these cleanup PRs that are trying to add to the scheduler util package, but we're ultimately trying to deprecate that. I believe you mean in favor of the external staging packages. Was that right?
Yeah, I guess the point is there's no point like in duplicating the code and moving it into the scheduler to actually cut the dependencies. What we should be doing is just try to have those utility functions themselves move into staging and used by all the other components.
Right.
So this is a much slower process, but it's the right process.
Yeah, I definitely agree with you on the duplicating codes part. We don't want to be doing that, and I don't want to do that. My question is just that we do have a couple other PRs that are really just getting rid of these helpers and moving them into the scheduler. So for the benefit of at least those authors of those PRs, would it be acceptable to, in a case where it's not duplicating but actually moving, collect these helpers in our scheduler util package so that on our own time we can eventually break those out and get the contributions from these people that have been trying to help just kind of move this cleanup effort along?
Yeah, I guess it's a case by case. So just please ping me on those two PRs, and I'll take a look.
Yeah, I just wanted to check that. And sorry for using up more time over that, but thank you.
Okay, thanks. So that is pretty much for our agendas. I have some update on the post filter, or we call it preemption extension point design and implementation. So I think I will go with the post filter suggestion given by Bobby, and I have the PRs in place for two phases. The first phase is to do prefactoring about existing code. So no matter we go with post filter in this release or not, we can do that safely. So that is just prefactoring to, for example, there's a lot of things using the generic scheduler, but sometimes those kind of things can be refactored to stateless functions. So I have 3 PRs put in place to figure out all those kind of things and reduce the dependencies to, for example, like profile to generic scheduler to make them stateless as much as possible. So those 3 PRs are in place. And in phase 2, I have the real serious PRs going on, the defining the post filter extension point and the mood hard-coded preemption logic as the default preemption plugin, which adopts the post filter interface. So that is also ongoing. I will raise up PRs later, but maybe this week or early next week. So that is the status. And any other ones have some questions related to share, feel free to speak up. All right, I think this is pretty much for today's meeting, and thanks for joining this meeting. We will see you maybe the next week. Yeah, thank you guys.
Thanks.